Today's lesson is on how do we connect representations of functions. A 10,500 gallon swimming pool needs to be emptied. Exactly 1,500 gallons have already been pumped out of the pool and into the tanker. How can you determine how long it will take to pump all of the water into the tanker if it pumps 750 gallons per hour? Take a second to copy down the question and a quick sketch of the graph because we're going to draw the graph as well. So now we have to look closely at our graph. Here, the Y is the water in the pool and the H is the time. So I'm going to draw the graph, and that's going to help me determine how long it will take to pump all of the water out of the pool. So it's a 10,500 gallon swimming pool. Exactly 1,500 gallons have already been pumped out. So if I do that 10,500 minus the 1,500 for everything that's been pumped out already, I am going to start at 9,000. Now, the pool loses 750 gallons per hour because this 750 is being pumped into the tanker. So this is what the pool loses each hour. So here, if I do 1,500 divided by 2, each value on the Y is going by 750. So if it loses 750 each hour, I can go down 1 and to the right 1 for 1 hour. Then for 2 hours, it loses another 750, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I can draw my graph through all of these points. And then I can see that it would take 12 hours to empty the pool. Now we're going to talk about this function for a little bit. This function is a linear function. I know this function is linear because it has a straight line. I also know it's linear because it has a constant slope or rate of change. Each hour, the pool is losing 750 gallons. It doesn't change when it gets to be more hours or when it gets to be less water in the pool. So it's constant. It is losing at the same amount each and every single time. So this is a linear function. The second question. Determine if each of the graphs below represents a function. If it does, state if it is linear or a nonlinear function. Take a second to draw a quick sketch of each graph and leave space to take notes after each graph. In order for a graph to be a function, it must pass the vertical line test. The vertical line test means that all vertical lines touch the graph one time. If a vertical line touches it twice, then it is not going to be a function. So if I look at this first one, I'm just going to start right in the middle and draw a vertical line. That touches my graph one time. Now I have to test out multiple vertical lines. So all of these vertical lines here only touch my graph one time. So yes, this is a function. Now it also has to state if it's linear. My function here is this straight line. Since this is a straight line, this would be a linear function. Now I look at my second one. I draw a vertical line here. That touches my graph one time. Line here touches it one time, one time, one time, one time, one time, one time. All of these vertical lines touch my graph one time. So yes, this is a function. Now I have to state if it's linear. If I look at my graph went up here and then it curved. This is not a straight line. In order for it to be linear, it has to be one singular straight line. So this would be non-linear. Now if I look at the second one, I'm going to draw a vertical line here. This only touches my graph one time. It may look like it touches it twice, but that's just because of the thickness of the line. So this vertical line touches it one time. Here, one time, one time, one time. All of these vertical lines touch it one time. So yes, it is a function. If I look at the graph now, it's this curved U shape. That does not look like a line, so this would be non-linear. If I look at number 4, if I draw this vertical line, it touches it two times. Since it touches it more than one time, this is not a function. If I look at this circle, I draw my vertical line. It touches it two times. Since it touches it twice, this is also not a function. And if I look at the last one, if I draw a vertical line here, that touches it once, one time, one time, one time, one time, one time. There's no way for me to draw a vertical line that will touch it twice. So yes, this is a function. Now if I look at the graph itself to determine if it's linear or not, I'm going to look at the graph. Here it goes up and down, back up, and back down. Even though each one of these parts is a line, it needs to be one singular straight line, so this would be a non-linear graph. And the last question. Determine if the tables below represent a linear or non-linear function. Take a second to copy down each table. In order for a table to be linear, it has to have a constant rate of change. So here I look, this is going by +4, +4, +1. Here my x is increased by 1, increased by 1, increased by 1. So if I do 4 divided by 1, I have 4. 4 divided by 1 is 4. 1 divided by 1 is 1. So this would be not linear. If I look at the second one, here, 10 to -2, I'm decreasing by 12. -2 to 0, I'm increasing by 2. 0 to 6, I'm increasing by 6. -3 to 1, I'm adding 4. 1 to 2, I'm adding 1. And 2 to 5, I'm adding 3. -12 divided by 4 is -3. 2 divided by 1 is 2. Since I see that these are not the same right away, I don't even care about the rest. This would be not linear. And the last one. 3 to 7 is plus 4. 7 to 28 is plus 21. And 28 to 52 is plus 24. 0 to 2 is plus 2. 2 to 5 is plus 3. 5 to 7 is plus 2. 4 divided by 2 is 2. 21 divided by 3 is 7. Those are not equal, so this would be not linear.